Welcome to qnawire.
We have a projectile and we're asked to find its rate of spin and its rate of precession. And I drew a free body diagram here and labeled the rate of spin as omega s and labeled the rate of precession as omega p. So we'll start the problem by finding the moments of inertia of the projectile about the point G. So for the x component of the inertia, I'm going to write that as m times k of x squared. And we're given the mass as 100 kilograms. And we're given the x component of the radius of gyration as 0.1 meters. So we'll get an x component that's equal to 1 kilogram meters squared. For the y component, we write that as the mass m times the y component of the radius of gyration squared. So we plug in the mass, and we plug in k of y, and this will give us an inertia, a moment of inertia that's equal to 6.25 kilogram meters squared. So next, what we can do is we can write the angular velocity in the x direction as the x component of the angular momentum about point G divided by the x component of the moment of inertia. So we plug in h of gx, which is given as 0.5, and then we plug in I of x, which we calculated to be 1. So the angular velocity in the x direction of the projectile is going to be equal to 0.5 radians per second. So now we do the same thing for the y component. So we take the y component of the angular momentum divided by the y component of the moment of inertia. So we plug in h of gy, and then we plug in I of y. And we'll get an angular velocity that's equal to negative 0.0016 radians per second. So now looking back at the free body diagram, we can see that to calculate this angular velocity, omega p, we can take the y component of the angular velocity and divide it by the sine of this angle. So the angular velocity of the precession is equal to negative omega y divided by the sine of theta. So the rate of precession is equal to negative 0.0016 divided by the sine of 6. And we'll get a rate of precession that's equal to 0.01531 radians per second. And we're going to look back at the free body diagram, and we notice that this x component of the angular velocity, we can get it by taking this rate of spin and adding it with the x component of the rate of precession. So to write that out, we're going to say that the x component of the angular velocity is equal to the rate of spin plus the x component of the rate of precession. And we're going to take this and solve it for the rate of spin, since that's the value that we're interested in. So now to get this rate of spin, we plug in omega x, which we know is 0.5, and then we subtract the rate of precession, which we've already calculated, times the cosine of 6. And we'll get a rate of spin that's equal to 0.4847 radians per second.